I'm going to start this video with a function already pasted in and ready to go. If you like to follow along while watching videos, just pause this video now and type out the function. Before we dive into the internals of this function, let's just talk about what it does. This is a function called popular films, and popular films takes two arguments. It takes n, the number of films to return, and a rating. And what it will do is return the n most popular films based on how many times films has been rented out. And it also supports an argument where you provide the rating. If you provide a rating, then it will return the n most popular films with that rating. So let's first have a look at using this function, and then we'll come back around and we'll talk about how it's been implemented. We can write a select statement using the function. And I want to obtain the 5 most popular films that are rated PG-13. So the function has just returned a table of results. Let's change n to perhaps 3 and run that again. Now we get 3 films returned. Let's change the rating. We'll change it to R. Those are the 3 most popular R-rated films based on the number of times they've been rented out. And I mentioned that the rating was optional. If you don't provide a rating when you're calling the function, it will default to looking at the most popular films that are rated PG. So let's try that. Let's remove the R. So this should just return the 3 most popular films that are rated PG. And it does. Okay, so now we know what the function does. Let's return and look at how it's been implemented. The function definition starts with create or replace function and then gives the function its name, and you specify in brackets after that the arguments that the function takes. I've prefaced all my argument names with p underscore, where p is just short for parameter. I do that so it's clearer when you're actually reading the body of the function to know when I'm referring to that parameter. So this function takes 2 arguments. One is n, the number of films to return of type int, and the second argument is the rating. The rating is optional because I've specified it to have a default value. If I didn't specify a default value for the argument, then it would be a required parameter. The next thing I do is specify what the function returns. In this case, my function just returns a table. So I simply write returns table, and in brackets I list out the different columns that will be in the returned table. I next specify the language as being SQL. So this function is going to be written in SQL. In the next video, we'll be using the language PGSQL. The next thing I write is as, and then you see what are called dollar quotes. Dollar quotes are actually just basically string literals that have built-in escaping. So when you provide a function, you actually provide the function as text. You could actually just imagine replacing these dollar quotes with the single quotation marks. So by using dollar quoting, it makes the function body cleaner and easier to read. But really, you can just think of the function body as being provided as a text literal. The function body itself is just a single select statement. It joins from the rental table onto the inventory and the film table, and it groups those results and performs a count to obtain the most popular films for each rating category. To refer to the parameters that get passed into the function, you can simply use their name. Alternatively, you can also reference parameter names by their position in the parameter list. So p_rating is the second argument that got passed in, so instead of writing p_rating here, I could write $2, and instead of pn here, I could write $1. I can recreate this function now. I can run the function again, and it works just the same. You'll still find people writing functions in this style, but I think it's nicer and more readable these days to just refer to the parameter name. This function returns a table, which is in essence just a set of records. Writing this as returns table is the more standard approach, but an alternative way of achieving the same thing that you'll sometimes see used is what are called out parameters. So let's change this function now to use in and out parameters. The function behavior will be the same. This is just another way to write the same thing. In the argument list for the function now, you specify if the argument is something that gets passed in or is returned out to the caller. Our first two arguments get passed in. And what gets returned out is all those columns that we listed here. So let's list those as out parameters. And now, rather than writing returns table, we can simply write returns set of record. So this is functionally identical to what I just had, it's just an alternative way of writing the same thing that you'll sometimes see. If your function just returns a single value rather than a record or set of records, you can just specify the type itself after returns. And if your function doesn't return anything, then you just specify a return type of void. For example, this might be the case if your function just modifies data, performing an insert, update, or delete statement, and doesn't return any results. Let's just write a very silly and very simple function now to demonstrate returning a single value. I'll write a function called mySum that just adds two integers together. So this function is called mySum. It takes two arguments, a and b. It returns an int. It's written in the language SQL. And I can define it with a very simple select statement. Let's create this function and then use it. And that worked as expected. If I were writing a function in production that didn't depend on any underlying tables or data, and simply just worked with the arguments that it was given, much like this mySum function here, I might also declare the function as immutable. I would do that by writing immutable here. And by writing immutable, this essentially provides a hint to the optimizer about ways that it can optimize the use of this function. There's a variety of other properties that you can specify for functions, much like immutable here. Let's look up the official documentation page for the create function statement and look at some of those options. As you can see, there's quite a lot. We just made use of immutable, but there's a variety of other options as well. You can read more about them in the description. One quite useful one that you might find yourself using often is returns null on null input, and this will ensure that if anyone calls the function and provides null for any of the arguments, the function itself will simply return null. And if I wanted to do that for the function that I had just written, I could list that here under immutable. So that's the fundamentals of creating functions using SQL. In the next video, we'll look at creating functions using PL/PG SQL.